Hello everyone, I hope that my microphone and everything is working very well. Let's see, I'm going to turn this all up. Okay. Oh, I have a little bit of... There we go. Got the green screen moved a little bit, so we are good to go. Let's see, let me mess around with my volume for a second. So today we're going to be going over graphing linear equations. We're going to be graphing linear equations. We are going to be going over the grid system, the XY axis, ordered pairs, and the origin. As you can tell, I don't have everything set up. I kind of had a few little hiccups this morning. I don't even have my... Oh, I do have my coffee. I don't have anything else, though. There we go. Okay, so I think the audio is going very well. I don't have anything set up properly. But what we will do is we will just go through it together, right? So let's move on to the actual slide here. And let me... There we go. So we have our first set... Oh, sorry. We have our first set of definitions. So as you can tell, we have our grid, right? We have our grid, and there is the coordinate grid. And as you can tell, there are two lines on our grid. It is the x-axis and the y-axis. The x-axis goes horizontal, and the y-axis goes vertical. So what happens when you have your x-axis and your y-axis? Think of it like, have you ever played battleships, right? So we have battleships, and you call out your locations to sink the other person. And it's in battleships, it's always a letter and followed by a number. So like column A and row 4, and maybe you got a hit, right? But so just very similar to your battleship game, your number line, your x-axis and your y-axis are numbered. So let's go ahead and let's put a couple of numbers on there, just so you have a better idea. So we have we have 1, 2, 3, 4 lines. So this would be 1, 2, 3, and then 4. And then this arrow here means that it goes out for infinity, okay? So it goes out for infinity. Same with all of these arrows, right? So they go out in all of the different directions forever and ever, covering any combination of numbers you can possibly think of, right? And then over on the left side, so we have our positive 1, 2, 3, 4 on the x-axis, and then we have a negative 1, negative 2, negative 3, and a negative 4 right there. So to the left is negatives, and to the right, I suppose, hang on. So that's to the right to you guys. So, I just tore my book. But to the right, we have our positive numbers, and to the left, we have our negative numbers. And what do you suppose is right in the middle? What is it right in the middle? It is 0, 0. That is the point 0, 0. And so since we have positive numbers on the right side of the x-axis and negative numbers on the left side of the x-axis, what do you suppose the top numbers on the y-line are? What do you think the top numbers are? They are positive. So we have a positive 1, 2, 3, 3, and then 4. And then those going below on the y line, they are negative 1, negative 2, negative 3, and negative 4. And all of this is important for getting ready to graph your linear equations. You need to have this base idea. And referencing back or talking back to our battleship reference, right? So think of this as like your rows, your X lines are your rows, and your Y lines are your columns. And so if you were to say, okay, 2, 3. So where would 2, 3 go? So if I asked you, let's see how this looks on the screen. I'll go a little bit lighter. So if we wanted to graph the point, so points that we're going to graph, I'll put up here. So if we were going to graph the point 2, 3, where would that be on our coordinate system? So the point 2, 3, you go to the right 2, you go to on the x-axis. Your first number is always your x number. And so you go 2 to the right on your x, and then you go up 3, positive 3. So then you go up 3. So right here, we would have the point 2, 3. And that would be our point. Let's do another point. Let's graph another one. Let's go with the point -1 and 4. Okay? So we have the point -1, 4. We've been given these 2 points. We graphed one, and now we're going to graph this second point. And so do you remember the first part of your ordered pair? This is what an ordered pair is, which we will get to the definitions. I have them up there. We will go to the left 1. So we're going to the left 1, and then we're going up 4. So 1, 2, 3, 4. So this right here would be the point -1 and 4. And we would be good. We would be good to go. So let's see. How about we go over some of the definitions that I have, and then we'll kind of go through. We'll do a few more points. We'll draw a couple of lines, and then we'll go into graphing linear equations. Okay. So let's erase the mask that I have on, because it's never good to hammer people with text. So it is a visual representation of points or ordered pairs, if you want to write that down. So the coordinate grid, a visual representation of points and ordered pairs. Okay. So then what is an ordered pair? Well, we've already kind of referenced it, but let's see what it says. Is a pair of values, an x value and y value. The x value is shown first. So in your ordered pair, your x value is always first. Okay. You always have your x value as your first value, and then we have these things down here, which we haven't talked about yet. We have quadrants. So what is the quadrant? The grid is split into 4 sections. Yeah, this is a bigger definition. And those sections have unique properties. The quadrants are ordered by Roman numerals 1, 2, 3, and 4. So let's go ahead and graph our quadrants. Okay, so we have quadrant 1, we have quadrant 2, we have quadrant 3, and then we have quadrant 4. There we go. So we have our 4 quadrants, and then to talk a little bit about the special properties of the numbers inside of each quadrant, you can kind of see this. So like right here, we have 2 and 3. What's unique about 2 and 3? They are both positive numbers. So what I'm going to do is I'm going to write an ordered pair, but instead of numbers, I'm going to put a positive and a positive right there. So we have 2 positive numbers. Quadrant 1 has 2 positive numbers. Quadrant 2, they have 1 negative number. The x is negative, and then the y is positive. Okay? So the x is negative and the y is positive to be in quadrant 2. So if I told you the point -5 and 1,000, right? We can't see it on our graph, but you know what quadrant it is in because it has the negative x value and a positive y value. So you can still define the point without seeing it. You can say, hey, -1, +1 billion. That is in the second quadrant. So it's kind of useful. It's actually really useful when you think of it, because then you can go into numbers that are way bigger than what we're used to and still have an idea of like the properties of it, the location, even if you go far, far, far out, or really, really, really tiny, right? It's a way to define your location on the quadrant or on the coordinate system. So, quadrant 3, what points would be in quadrant 3? We have a negative and a negative. And then lastly, we have quadrant 4, which we have a positive and a negative. Okay? So, if I were to give you the point, what quadrant would the point, let's go -7 and -11. What quadrant would that be in? Not equals, but so what quadrant is the point -7 and -11 in? Well, -7 and -11 would be in quadrant, we could put a Q3, or we'll just do our Roman numerals way up in the corner. Boom, we have our quadrant 3. I know where it's at. I can't graph it on my graph that I have because I don't have room, right? My graph didn't expand out that far, but I have an idea of where it is. And then lastly, our last definition for the coordinate system, we have the origin. And we've already put the point on the origin, the center of the grid, the intersection of the x-axis and the y-axis. It has an ordered pair of 0, 0. The part here that I always got interested in is it's 2 dimensions, right? So like it's like you're looking at a piece of paper in a way. And this x number line goes off into infinity. You have all of your integers, all of your positive and negative integers. You have 0. You have all of the decimals, right? You can really go into detail, and you can go into very, very small numbers. So anytime that you've ever graphed in the past, it's going to still have like no matter what number line you've ever graphed on, it has all of these numbers, right? So I found that kind of fascinating, kind of interesting, right? It's a way to describe things that you normally can't, and you can tell where things are at. How about we just draw a line? So we could, well, let's go on. Let's go on to our next graph, or our next page here. So we'll get rid of all of that and all of that. And then, oops, I don't have my mask on. Oh, I didn't put a mask on. Oops, that's okay. So here is our definition of a linear equation. Okay, so it says linear equation, an equation that forms a straight line when graphed. All of these solutions of the equation on a line, all of the solutions to the equation are on the line, and you must have 2 points. So let me bring back up this. There we go. So we can go ahead and we can erase. Let's erase all of this. Oh, I don't have my other mask on. That's interesting. How did that work? Okay, we can go ahead and erase all of this stuff here. And we can still use this. We can use this. We can salvage this. Let me... erase my last slide. Sorry about that. We have a lot of stuff on the screen. Okay. There. We are good to go. So, a linear equation. So you must have 2 points, right? Well, earlier we had those 2 points. Let's just come up with another 2. So we will graph the point Boop. So the point, let's go with 2 and 4. And then we will graph the point -1 or -2. I wrote a -2 and -1. So this is going to be our we're going to just graph these 2 points and we're going to see what happens. Okay, so we're going to put, let's go with this purple color. So for our first point, we're using purple and it's at 2, 4. So what quadrant is 2, 4 in? I was talking about it earlier. What quadrant would 2, 4 be in? It would be in quadrant 1 because both of the numbers are positive. Remember, this is quadrant 1. So the point 2, 4, you go to the right 2 spots. So 1, 2, and then you go up 4 spots. So 1, 2, 3, 4. So this would be the point 2, 4. Our ordered pair, we write our ordered pair. Boom, we are good to go. Then our second point we will do in this kind of like bluish, yeah, definitely not any other color to describe that by, but bluish. So -2, -1. What quadrant would -2, -1 be in? That is quadrant 3. So 1, 2, 3. So this is our quadrant 3 down there, right? Boop, right there. So we have -1 or -2. So we go to the left 2 spots from our origin. Always start at your origin. To the left 2 spots. So we 1, 2, and then down how many spots? Because it's a negative number, right? So then we go down 1. And there, that's a little bit, we'll go a little bit darker. There we go. So we have our 2 points. And it says to graph a straight line, we must have 2 points. And I will do my best to graph a straight line. Let's see. We will go with yellow. Let's see how yellow looks. That does not look good. Okay. We'll do this dirty yellow. And... oh, I missed. No, it's so hard to draw a straight line. There we go. There. I'm pretty proud of that, for that being freehand. And then the other component with a line that's important to know is it goes off in these directions forever, right? So every single line, if it is a line, not just a line segment, if it is a line, it goes off for infinity, okay? I'm a little bit bigger than what I normally am. Let me shrink myself down. Ooh, okay. There we go. This is a little bit more comfortable for me to be this small. Okay. So we have our line, and there are all of these. So when you draw this line, it means that like you're giving a definition or you're giving some type of description of a location, and there are all of these other points, right, in between these 2 lines. If I had a straight edge, I would graph it. So we have all of these points, right? So like what a line is it's just made up. It's an accumulation of all of the points. And a linear equation is a way to represent a whole group of numbers, all of these numbers on this line that goes out for infinity. There are infinite numbers on this, and you will have a couple of graphing problems on the GED. I will say that. You will have a few. I'm curious. I'm so curious. I wonder if export is in here. I know I started class a little bit later than usual, but it would still be kind of cool. But who knows? That's okay. If export is not in here, then that's understandable because I was late. So let's go on to erase all of this. Oh no. Actually, yeah. We'll erase this and then we'll start graphing. We're gonna graph these problems here. There we go. Let's erase that. Okay. And then let's talk a little bit about our problem here. So we have the equation of y equals 4x minus 3. So 4x minus 3, and they're asking us to graph this line. So how do we go about graphing this line? The very first thing that you should do when you're first getting started out is make a little table. So we are going to make an x, y table. And if you notice, we have an x and we have this x here, right, on the grid. But then we also have the y, and that is also on the grid. So what you can do is, sorry about that. Whoops. Let me put my phone on silent. There we go. Hey, that's okay, export. Totally fine. Totally fine. This is good. It's good information, and I get this feeling that you probably know a considerable amount about. I think you're probably already good with graphing. I would bet money on it that this is not too bad, not too difficult for you. So with our x, you have an input, right? So your x will always be your input. So input, and your y's will always be your outputs. There we go. Boom. So we have our inputs and our outputs. So for every equation, you always have an input and an output. And think of it like a little machine, right? So you have your input, you have to put something in. You have to tell it that initial value. So you say x is equal to something. And I always do the same 3 points when it comes to graphing these linear equations. For the most part, I will always do the same 3 points. And that would be, we will go with a -1, a 0, and a +1. Those are our easiest points to graph, and that's what we're going to just stick with. You can pick any points that you want to, right? But I'll say for the most part, normally, under normal conditions, -1, 0, and 1 will be the easiest ones to graph. So what that means is that you have to plug in for your x value the ones that you're telling it to, right? So we have to go through and solve y equals 4, and then put a 1 in for your x, and then -3. So 4 times 1 is 4. 4 times 1 is 4. And then -3 is 1. So our y equals 1. So we'll put that there. We'll put that in our column. And then you have 0. So when you take 4 times 0, it is 0. And then 0 minus 3 is -3. Yeah, perpendicular and parallel lines. We'll get to that. I think we could probably talk about that a little bit today. I am going to show how it works, like why when you change the numbers in your equation, why that kind of changes how the line looks, right? And part of that would be perpendicular lines, right? So 0, when you plug 0 in for x, you get a -3 for your output. And then for your next input of 1, oh, I did the 1 already. Uh-oh. See, it's just always never fails. I always mess up something. So let's go back. So I did a +1 right here, if you didn't notice. A +1. That's this answer. So a +1 for our input gives us a +1 for our output. 0 still gives us a -3 for our output. And then lastly, when we plug in y equals 4 times a -1 minus 3. What is a 4 times a -1? You have a -4. So y equals -4 minus 3. And what is a -4 minus 3? It is more negative. Okay? So you're getting more negative. So -4 minus minus 3 is a y equals -7. So -7. And here's the kind of rough part with this one. My graph only goes up to 4 on any direction. But we have a -1 and a -7. What quadrant is a -1 and a -7 in? That would be, so quadrant 1 is on the right, top right. So 1, 2, 3, and then quadrant 4. So what quadrant would our point -1, -7 be in? Well, that would be quadrant 3, because all of the numbers in quadrant 3, all of the ordered pairs, are both negative. So it would be somewhere, so -1 and then -7. It'd be somewhere probably down. That's 5, 6, 7, probably like way down over here, somewhere in this area. Okay, that would be -1, -7. I'll put that in red just because it's way off of the grid. So our next two numbers, we're good. We're lucky on that. We have our two other ordered pairs, so it's 0 and -3. So just to clarify, so we have our points that we are graphing for this line, and that is -1, -7, and then our second point is going to be 0, -3, and our third point will be the points 1 and 1. And this is your x value, your y, your x value, your y, your x value, and your y. So our second point is 0. So where do we move on that x line? Do we move anywhere left to right? Absolutely not. Our x is at a 0, so we don't move anywhere from left to right. But where do we move on the y? Well, it's 1. So our dot is right there on the x-axis, or on the y-axis, sorry. On the y-axis. This is not one of the points that we're graphing. Okay. Then our last point is 1, 1. So, with point 1, 1, what is that? Why do I have the 1 there? 0, -3. I think I've misread all different types of things. So the reason why I always pick -1, so the reason why I pick -1, 0, and 1, so you can pick anything that you feel comfortable with, right? It's just the math with picking -1, 0, and 1 is the easiest math to work with, in my opinion, right? Because what is 1 times anything? It's whatever it is, right? So when you have 1 times 4, it's going to be 4. When you have -1 times 4, it'll be a -4. So it's easy, it's fast. It's very fast. And if you did 2, sure, the math, the arithmetic is easy, but it's a little bit more brain processing, right? I want to be as efficient as possible, and usually this -1, 0, and 1 will be the easiest, fastest ones for you to do in your head, right? And time does matter. Time does matter on the GED test. But you can pick any numbers that you want. Any of them. We'll do a couple of examples. We'll do some of these examples. We'll pick some real random numbers. But not until after I get through some more of these. Okay? Okay. So, I messed up on that one point. So -1, -7 is here. 0 and then -3 is here. So this is 0, -3. Okay. The other reason why I like doing the 0 in the -1, 0, and 1 is you'll always have a point on that axis. You'll know when it crosses the y line, right? If you always pick the x of 0, you'll always know the y. It's called the y-intercept. It's where the line crosses the y-axis, okay? Really good identifier, and they might ask you something like that, where it's like, here is this linear equation. What is the y-intercept, right? Which all they're asking there is, where does it cross the y the y-axis? Where does it cross the y line, the vertical line, okay? The main vertical line. And so if you plug 0 in for x, you will always get your y-axis. And when you think about it, no matter how you draw a line on this graph, it will always cross the y-axis unless it is totally vertical, right? Perfectly vertical. But any other line, even if we draw like a line like this, right? Tiny little baby line up there, it will eventually cross the y-axis. You'll eventually have a y-intercept. So there's only one type of line that will not cross the y-axis, and that is something like, let me see if I can remember it. I should remember it. Y equals 1, right? So if I just said y equals 1, that would just be like, oh, your y values you can plug in different y values, but I'm just saying it's right on that vertical line of 1, and it's just perfectly vertical. That I don't want to get too deep into that because that can you can get into some crazy math with that. It's fun stuff, but I can feel my brain wanting to pull towards like theoretical ideas of that, because that's called, you have some math problems later on. If you go into math, you have asymptotic lines, or an asymptote, where it's like an invisible wall in your equations, where it's like, oh, what happens when it runs into this wall? Well, poof, it shoots up to infinity. Kind of fun stuff, kind of neat. Okay, so we have our points 0, -3, and then we have to graph the last point of 1, 1. And with the point 1, 1, we will use pink. So we have 1 to the right, and then 1 up. So 1, 1. Put our dot there. And then we will graph this line. I'll use green. Oh, let's see. Can I get a straight? Maybe I can use this as a straight edge. It's kind of weird not having a piece of paper and trying to use a straight edge. Oh, I'm getting closer. Oh, look at that. Nice. I got a line. Yeah, it's green. It's hard to see, but it looks straight. It looks straight, so that's good. Okay. So here is our line, the green line. It crosses through the points 1, 1 and 0, -3. And if you actually kind of eyeball it, it does kind of look like it's heading towards, it looks like it's heading towards our point of -1 and 7. You put your arrows. Always make sure you put your arrows, because that's telling you that it's going out for infinity. And, whoops. And then, this line describes all of the answers. It is like the master answer for your equation. Okay? So when you graph this line, any of these points it crosses, it's an answer to it, right? Right here, when y is 0, it looks like we're 3/4 of the way through 0 and 1. So check it out. If we did that, if we did the algebra, plugged in 0 for y, and then did the algebra to solve this problem for x, we would get 3/4. That would be our answer of when x is 0, or when y is 0. Sorry, when y is 0, our x would be 3/4. So our x-intercept, which I'll put a little red line right here. This is called your x-intercept. Okay. Boop. And this line down here is your y-intercept. Those are important terms. I don't have them down. You can abbreviate intercept as INT. You can shorten it to INT and you're good. But that is us kind of graphing this first line. And let's see if I can clean this up a little bit. So far, not too terrible. I erased my 2. I just want to clean it up a little bit. I mainly just want us to keep the line. So let's go ahead. We will regraph our points. So our points on the line, so that would be 2, 3, 4, -1, -2, -3. Okay, so let's go ahead and we will do the same thing, right? The exact same deal on this next equation. And I want to put these 2 lines up against each other so you can kind of see a little bit of the difference. The only difference in the equations is that I put a negative sign in front of the 4. And that does some things. That totally changes your set of solutions to this equation. Totally changes what you will get for outputs, right? You can still use the same inputs, which that's why I like to stick to that x and y. Let me make that a little bit more straight. Boop, 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 boop. So x, y. And we will still stick to our -1, 0, and 1. Okay, so when you plug in a -1 times the -4, you get a +4. -3 is a +1. 0, you still get the -3. And then when you put in the 1, you get negative. So you get a -4 -3, a -7. And so if we look at this, it's just so similar. The only differences are a couple of signs, right? So it's -1, 1. We'll go with red. So our first line, line 1, is green. I will label it. So this is line 1. And then line 2 we'll do in this nice red color. So -1 and -7. So that would be way down here again. Oh, I read the same point. So -1, -1 is here. No, it's not. Sorry, guys. Sorry. My brain. Okay, it's Monday. It's definitely a Monday. -1 and 1 is here. And then a 0, -3. So 0 and then -3 is right here. So it crosses the y-axis at the same point. And then 1, -7. So it's way down here. So if I were to graph this, let me see if I can get kind of close. And almost. Getting warmer. Nope, not quite. Close enough. Okay. So we have line 2. And now you were talking about perpendicular lines earlier, and with perpendicular lines, the main thing that changes is this number right here in front of it, right? And if you notice, like if we keep kind of moving this line around, we can keep going around this point, because so this is our y-axis. So what you can do, like the big step here, we're almost there actually, with a perpendicular line, is your first number is the inverse of this of your number before, right? So if we have y equals 4x minus 3, a perpendicular line, so a perpendicular line would have y equals, and then instead of a positive 4x, we'd have a negative 1/4 x. minus 3. And so that would give us our perpendicular line. Okay? The other part, parallel lines, with parallel lines, you have the same slope. So let's see. Oh. Okay, so what you have with parallel lines, you always have the same slope, which means it changes at the same pace. I actually didn't prepare to talk about slope too much, but your slope, so we'll talk about slope-intercept form, which all of these lines are in slope-intercept form. It's just a lot to take in a single class. Oh my gosh, yeah, it's 10-12. So I will finish these two examples up. We'll talk briefly about slope-intercept. I will erase all of this stuff, make my eraser much bigger. Okay, so we have our second line drawn, and we can actually go ahead and erase these now. Now that we are done graphing those two, the main thing I wanted to demonstrate was how it still crossed that y-axis. It still crossed at that 0, -3, but the direction changed, right? If you were looking at it, so let me back it up again, and then I'll erase. So notice how this line 2, let's see, can I go any farther back? I cannot. But line 2 is going down from left to right. So line 2 is down from left to right. Line 1 is going up from left to right. So up from left to right. And that is a little bit important, because what it is if you notice, the only thing that I changed was the sign in front of the 4. We changed the sign from a +4 to a -4, and that is what changed the direction here. That is why it went from going down from left to right to going up from left to right. And that's kind of a powerful little bit of information. You can change what direction any of your lines are going in. A lot of people, right? A lot of people, they're like, hey, when am I going to use this? But when you think of different video games, if you ever play any video games, they're made up of polygons. They're made up of shapes, right? Shapes that have lines. There's three-dimensional lines, right? Not 3D lines, but the shapes have, well, they're two-dimensional shapes, and then they can make three-dimensional shapes out of them. But the directions of your lines inside of a game, the first games were like Pong. It was just two parallel lines, right? And you could control them, and they're always going to be parallel, right? So there's a math equation that would describe that movement, and there's equal distance between those two points, and then one dot will bounce between the two things that you're moving on Pong, right? One of the best video games to ever exist. It started the whole video game world, basically. But yeah, it's kind of neat. It's kind of neat. All of these things, when you take them farther and farther, it will eventually, you can be like, oh, I'm going to use that, right? It's just your choice. It's whether or not you choose to use it, or you go into a field that uses it heavily. But even if you choose not to use it as a job, if you play any video games, it's in there. All of this math is in there. This explains so many of the things, right? When you play any type of game, a shooting game, it's okay, well, recoil, straight line shots, right, from your gun. When you think of, like, I don't know, I'm just thinking of Counter-Strike. I used to play Counter-Strike, right? And you shoot your gun, and there's some drop in your bullet. And so, like, okay, the slope, the line is not perfectly straight, but if you're close enough, it will be perfectly straight. And so it's like, oh, it's a straight line that describes that shot, right? So Counter-Strike, video games, like any bit of technology today, We use this stuff all of the time. Okay, my best job of not totally erasing the entire graph. Okay. So we will move on to our next two examples. And I might have time to go a little bit deeper into slope. Slope and all of that, it's probably better to save that for tomorrow's class, just because of there can be a lot to it, right? I'm gonna show slope intercept form, which that is what we're looking at up here, but I want to go a little bit deeper into what slope intercept form means. There's ways to do those things very fast. Good. I'm happy that you picked up that example. But so you have x minus 3, which that would be, so you still want to do your little table. There we go. So we will do our table over here. So we have x and y. And now I still will always stick to just my habit. Let me make it a little bit smaller. I'm still going to stick to 1, 0, -1. And when we plug those in, we have 1 minus 3 is -2 for our first input and output. So our first ordered pair is 1, -2. Oh. And our second ordered pair, so when you plug in 0, you get 0 and -3. So we get -3. Our second ordered pair is 0, -3. And then our last one, -1. So -1 minus 3, you're getting more negative. So -4. -1 minus 3 is -4. So our last point is -1, -4. And we can go ahead and we will graph these with blue. So all of these points will be blue. And so you have 1, go over 1 on your x-axis, and then down 2. And then 0, and then -3. And then -1, -4. And I'll draw my line as straight as what I can freehand. We will then do our last example of x and y, draw our table out. So yet again, I just changed that sign of the number in front of your x value. And what is in front of your x value? It's your implied 1, right? It's all that implied 1. That's why you can put it as -x. You don't always have to write your -1. Okay, so when we plug in 1, 0, and -1 into this one, we have 1 times the -1, which is -1, minus 3, which is -4. I probably should not. I'll use this light blue for that side. -4. 0, you get the -3. And then -1 changes to a positive. So +1, -1 times a negative is +1. Minus 3 is -2. Okay, so we go through and we will graph this. Yep, so we have 1 and -4. So 1 and -4, 1, 2, 3, 4. Let's change the color into more of this pink color. So +1, -4. 0, -3, and then -1, -2. What's another way of thinking of this when we do this, right? It's almost like it's flipping it in a way, right? It's very, very useful. You're just shifting that direction of that line. It's your mirror. They're still perfect kind of like mirrors of each other. You can just flip it like a pancake, right? Oh, the -4. So 1, So here, I'll do this. So y equals, how I got this -4. So we have our negative number, and then we put in, our input was 1, right? -3. So then the negative times the 1 is a -1 minus 3. So y equals -1 minus 3. And -1 minus 3, so you owe someone money, and then somebody else comes up to you and says you owe them more money. So you are deeper in the hole. So y equals -4. So that's how we got our -4 there. Okay? Not too bad. Not too bad. And so you're taking your test in a month. And I mean, I think it's just us watching. I think I only have one viewer today. A little bit less than a month. You should be fine. I think you're going to be just fine, most likely. If we work together in person, I would probably see what you're working on, and you'd be good to go. You'd be good to go. I would still just stress inequalities and rational expressions. Those are your two big dogs on inequalities, rational expressions, polynomials, and factoring. Those are your big things on the GED test. But I am losing my voice because I didn't do classes over the weekend. So we will call it good there, export. Let us, tomorrow, I will get in deep. I'll go in deep into slope-intercept form. We might even talk about point-slope form. And then we will kind of continue on from there. We will eventually, I will get into a little bit of geometry, but not heavy. Actually, when I was teaching the GED, teaching for the math section for the GED, I wouldn't even teach geometry, really. I would teach all of this stuff that I have been going over, and then geometry, you're going to get one, tops of 2 questions, and it's going to be a formula-based question. You're going to be given a formula and told the dimensions of the object, and you just plug it in, and you're good to go on the geometry section of the GED. It's not difficult, not hard. Yeah, your other rational expressions, polynomials, solving binomials, those things are the most important. I actually had one student, I won't even call the person a student. I had someone that did not do well with fractions. They couldn't work with fractions at all. They didn't study for fractions. It was just a tester. It was somebody coming in for testing. And they passed. They passed the test. Oh, the previous question. -1. Oh, you're right. You're 100% right. What should that... Or wait. Oh, yeah. Same idea, though. Same idea. Same idea than this one. When you plug that -1 in, minus the 3. So it goes into a -1 in your x value, minus 3, which equals -4. Yep. It's super messy there. Let me back it up. I will erase that. So we have our... So what I did is I plugged in -1 for the x value, minus 3, more negative, and then y equals -4. And that's how we got that -4. Right? Kind of the same concept, just a little bit different than the other problem. But, yeah, all right. So we will call it good there. Always glad to have you, Export. Always appreciate you coming and hanging out. I have thought about actually streaming, but we'll see how it goes, right? I don't even know. I haven't played any video games for a while. I used to play League of Legends quite a bit. League of Legends, chess. I mean, I have played Minecraft, right? But I don't think I'll do Minecraft. Maybe. It would be fun. I haven't played that game in forever. But, all right. Well, you guys have a good day. Thank you for watching. If you liked this video, make sure you hit the like button, comment, and subscribe. I appreciate you, and I hope you have a beautiful day. I'll talk to you later.